Welcome to our Project Hack 17 submission. This is Team No Code Continuum tackling Challenge 9. Well, this is the team captain Matteo Palo, Dan Hare, myself, Ben Banham, Elliot Atherley, and of course George Godfrey as well. Well, this is a challenge summary. Take a look at the problem statement. HS2 are moving towards net zero carbon emissions. HS2 must also identify good practice across their supply chain, must model, benchmark, manage all products and assets to reach that lowest carbon output. However, there's huge volumes of semi-structured data across the entirety of the supply chain, too large for those traditional tools. We need a repeatable, reliable, verifiable processing and analysis solution. Challenge accepted. Let's take a look, shall we? This is the overview of the required outputs. First, must normalize that data between the different output assets to compare the carbon impact between them, considering the size, project, and quantities of materials used. We utilize a tool, we love it. It's called Alteryx to do that analysis. Next, clear benchmarks of what makes a good project in terms of carbon emissions. We establish a nice RAG rating for the job. Again, establish that within Alteryx itself. Beyond that, visualization of data to show the concerned parties being as clear as possible for those non-technical viewers. We utilize a program course called Power BI for the job, fantastic visualization tool. Even beyond that, would you believe, machine learning to determine the features that contribute to the lower carbon assets. We use a program called Data Robot for that job. Well, here's an anatomy of our projects. First, of course, is to analyze all of that data, that disparate data sources spread across those myriad of different Excel files. Here's our Alteryx workflow to bring all of that data together into one unified, cleansed output that we could use confidently for our analysis. Next, we then took that unified data set and consulted the problem themselves and said, hey, look at this. This is what we've got. This is what we're thinking. Is this going to add value for you? They give a fantastic steer for us to help us then design our solution. We went to the literal drawing board, as you can see right here, to model what we think will be useful for this particular hack. And then, of course, we started building. Here's one of those Power BI visualizations, which we'll get into one moment. And then, of course, we presented it all on this very video that you're watching right now. So here's the solution. All those project asset folders spread across those Excel files, bring it into Alteryx, input, cleanse, join and transform all of that data to get it to a nice cleansed, unified set of data. That then is in the basis of our Power BI visualization for those KPIs, bring it into the machine learning model within Data Robot to determine those feature importances, what makes an asset good, what makes it bad, and then blend that back in, as you'll see, to integrate those feature importances back into the Power BI visualizations themselves. Right, we've seen enough slides. Hey, let's get stuck into the data itself. So here in Power BI, we're analyzing the global warming potential. That's our target variable in this analysis against the total asset mass. Is there a correlation? Let's find out. Well, as you can see here, all of the assets are plotted on this particular visual. You'll see the asset ID symbolized here. What we've done is applied a trend line, right? So what that means is this is the average. Anything above that average has a red rating. Anything kind of in the middle there has that nice amber rating. Anything beneath, of course, has a nice green symbol here, right? Now we can actually filter this based on the mass of the asset. Is it high, above average, and so on and so forth. Perhaps looking for certain important indicators. Maybe we want to take a look at perhaps asphalt in particular. We can filter this particular visual here. If we click on above average mass, we can see perhaps that's going to go ahead and change this visual accordingly, of course, as well as the table beneath, which shows some of those values itself. Just going into some material analysis here, I thought this was rather interesting. So what we did was we found out that in our machine learning model, which we'll get to in one moment, found out that the material itself was a big influential factor, right? Take a look at this particular asset right here. So we've got some RAG ratings applied to these different materials: asphalt, aggregates, concrete, and timber, right? So therefore, we can see since this asphalt bar is the largest, that means it has the biggest global warming potential for this particular asset. However, notice that bar is green. So that means that this asphalt, the utilization of asphalt in this particular asset is good compared to asphalt usage across all assets, even though it's the largest contributor to global warming potential in this particular one. However, take a look at aggregates. Okay, second in terms of global warming potential. However, that's red in terms of RAG rating because it's higher than the average for other aggregates in other assets. Interesting. And of course, we then have the same visualization here, but in terms of the module, the life cycle, right? So A, B, C, or D, and of course, all the subcategories within there. Want to get stuck into machine learning? I know I do. Well, here we are in Data Robot itself. What we did is we uploaded that data set from Alteryx itself, analyzing the global warming potential over the mass, and immediately it starts to analyze all of those fields, ordering it in importance according to that target variable we got here. What we did is we actually run the whole library of different Data Robot models containing over 140 machine learning algorithms, all run simultaneously, and as Data Robot determined, it's the graded, boosted, greedy trees regressor, would you know? that actually came out on top. Here's his particular blueprint of all the steps included in this machine learning algorithm. But of course, we did none of that because it's a code-free technology. Pick up and play at its finest. Let's have a look here. This model actually determined that the feature that had the massive impact was just the material that was used that had the biggest impact on the global warming potential. Having a look at those features, we found out materials such as gases, finished products, or electricity, they have the most impact on that global warming potential overall. Now we've created this machine learning model, it's deployed, it's ready to go. Here we can see it's ready to actually have some predictions put up to it, and now this model is in production. We can fire data up to it whenever we want to get real-time analytics on those predictive variables. Let's take a look at those results, shall we? What have we done? Well, we got a repeatable keyword Alteryx pipeline for all those projects and assets. We repeatedly get all that data back together. We've got an interactive Power BI dashboard, so the performance of those assets, and of course that machine learning model. Wasn't that brilliant for the global warming potential of all those assets? Material was that number one predictor we determined. And what's next? Well, of course, more data, right? More insights. That would add asset data itself. We didn't actually know what the asset classification was. Was it a bridge? Was it a railroad? All that sort of stuff. We'd add that in to get more accurate predictions, solve for additional important factors, perhaps a material efficiency metric, and then optimize the machine learning models accordingly. And follow that data all the way to net zero, of course. Here's our judges' questions. Take a look at our responses here. In the interest of time, I'll let you pause the video to take a look at these. Here's question 2. Take a look at those, of course. Pause in that video to take a look at those answers in a little bit of a more time for yourselves. And question 3. Thank you so much for taking a look at our submission. Best of luck to everyone else. Thank you.